the area between two curves. We know the application of an integral, which is to find area under the curve, correct? Sort of, it is a definition of an integral too, in a way. When you did area under the curve, you actually did area between curves. You just didn't realize it. Can someone tell me that you, in fact, as y, you found the area between curves and you simply did area under the curve? They're one and the same. You just didn't see it. In other words, you really did this section. Emily, what's your name?
Hannah.
Hannah, go ahead.
You're asking us to like explain how we've already done this before.
Yeah.
Well, if you do the area of like the top curve minus the area of the bottom curve, you get the area between the curves.
Yeah. How does that relate to area under the curve?
Because I can only explain it by like drawing it. But
Okay, but you are correct, Lorenzo.
You can view the x-axis as your second curve.
Very good. X-axis would simply be the second curve. So we all know area under the curve, right? Okay. It is, of course, a definite integral. Say 0 to 2. Call that 5. Do we need calculus for this? We know the answer already. What is the answer? 10. That is the area we are looking for, and you found the function. In this case, what is the function? F of x. In other words, y in terms of x. Easy question. Simplest function.
Y equals 5.
Y equals 5. Or f of x equals 5. That is my function. You integrated that between 0 and 2. Yes, in calculus 1, got the area. I just want you to think of the process in a different way. Have a function, yes, in calculus 1, 0 to 2, area under the curve, f of x, dx. So you've got 5 over there. Five out of the integral. Let's see if you remember stuff from the first class period. What is the integral of dx? X. Remember my squiggly. 5. X evaluated between 0 to 2. Upper limit, lower limit, answer is 10. Good. This is how you would have done in calculus 1. Is it coming back to you? I want you to reframe your thinking. Lorenzo says, this is what Hannah was trying to explain. When you did area under the curve, you actually found the area between curves. Upper curve, f of x. The lower curve is g of x, right? G of x is simply y. It is some function of x. If you have to represent this bottom curve, bottom line, in terms of y, what would that line equal to in terms of y?
Y equals 0.
Y equals 0. Same as g of x equals 0. With me so far? Yes? So that's what you learned here, how to think in a very generic way. 0 to 2, upper curve minus lower curve, dx. Yes, we already know what the upper curve is. F of x is equal to 5, so that would be 5. What is the lower curve? 0. That's that. Good. So since day one, when you were trying to find the area under the curve, you were actually doing area between curves. You just didn't realize it. One of the curves is just the axis. Good. So do we see what area under between curves is? Good. Okay. If you look in your textbook, Google, not Bing. Hopefully they don't sue me. But then Microsoft knows that it's not a great browser. So does Mac. Mac knows Safari sucks. Who likes Safari? I'm not judging. So if you Google Bing search, you will see f of x minus g of x. Some might write it as g of x minus f of x. If you want to be more formal, there's another way to write it. Any thoughts? You can either do it this way, that way, or you can just formalize it and write it as one expression. The first two cases require an additional piece. It requires a constraint here. The last formal case doesn't. I'll give you a hint. When you found area, was there a case when you had a negative answer? Could you have a negative answer for area? No, area can't be negative. So in this case, I don't want a negative answer. I would like to have that curve to be bigger than that curve. Correct? Do we know what that sign is? Means for all. Think of V for vendetta. One of my favorite movies. For all. Likewise, any thoughts on the constraint here?
Start backwards.
Backwards. Last case, I don't even have to specify a condition. I'm too cool to specify constraints. How can I guarantee that I'll have a positive area regardless of what f of x and g of x are?
Absolute value.
Very good. What's your name?
Alex.
Alice?
Alex.
Alex. Very good. Absolute value. I'll write it that way. It doesn't matter whether f of x is greater than g of x or g of x is greater than f of x. It doesn't matter. Always going to be positive. So if you look in the textbook, there are 3 different ways in which they would write. My recommendation to you, think of always upper curve minus lower curve. Easier way to remember. This way, you get a positive area, or stick with absolute value at all times. So you don't have to worry about the condition. Good. Very important thing to learn now, because it will show up when we do volumes. So if you are still facing Monday blues, wake up, ready. Oops, didn't use that. You have to take a guess, what is that curve? Exponential, and it's 0, I have 0. Can't be exponential. Another guess, you can do it. X equals y. That's not a line. Caleb, right? Help Caleb out.
Y equals x squared.
Y equals x squared. Right? Agreed. So it can't be exponential because exponential curve when x is 0, y is 1. Can't be that. Can't be y equals x because y equals x is a straight line. That's not a straight line, at least in my eye. So y equals x squared. Let's see, I pick 2. I want to find the area under the curve. Y equals x squared, 0 to 2. F of x, g of x. Good so far? One of the things that you should learn and get used to now is, the tiny strip. Did you all talk about this in Calculus 1? What does that strip refer to? Huh? Riemann sum. It's part of the Riemann sum, but that is not what the strip is. I kind of gave a hint when Michael said it's a Riemann sum. I said it's part of the Riemann sum, but it refers to something else. Lorenzo? Delta x. The tiny rectangle that you have, and this is the strip that moves along to sweep the area under the curve. And for some infinitely many such rectangles, you would end up getting the area under the curve. So understand, purpose of the strip refers to delta x. If I have a different scenario, let's say, Caleb, curve, you have to take a guess. Exponential, perhaps, right? Good. So anytime we have to find the area between two curves, we need to either have a proper boundary or we need to have a nice enclosed area. Otherwise, the area would be infinite. So if I didn't restrict at all, the area between the curves would be infinite. Do you agree? Keeps on going this way, that way, one way. But if I said between 0 and 2, you have a proper enclosed area. Agreed? And that area is right here. The upper curve is f of x. Lower curve, g of x. Put an absolute value if it's going to make things easier on you. And the strip, the delta x, you're just moving it here, from here all the way to there. Good? With me? And you sweep that area to find the area enclosed by two curves. In some problems, in some scenarios, they may not specify this point. If it is not specified, how do you find it? Look at the picture. Like,
Find where the two functions meet.
now
You find where the two functions meet.
we find that two functions meet, that's got a name. Fancy expression, Sarah.
Intercept.
Intercept, so close. Intersection. So it is the intersection point where the two functions meet. So you want to find the point of intersection between the two curves in order to find the limit of the enclosed area. So sometimes the homework will tell you from where to where. Other cases, you'll have to find the point of intersection. Finding that not so difficult. Good? Yes, no, maybe? There are cases where you might end up having 2 points of intersection, 2 enclosed areas. So you've got to add all possible values. For instance, simplest trigonometric function. I like to commit sin. Silent. Not exactly, but for the sake of it, let's just say it is. And that's my other function. Good. Now I want to find the area enclosed by curves. In a problem like this, they've got to be very specific. Do you agree? My eyes pick up multiple enclosed areas. Does yours? I can see one there, one there, one there, one there. Yes? Which ones are we referring to? The problem's got to tell you. So, one part, another part, another part, another part. So, in a problem like this, key things to know: 1, absolute value, or upper function minus lower function. 2, points of intersection. Good? Yes, no, maybe. Okay. Calculator is your friend, always. Some, let's say, can't use a calculator. I have different viewpoints. We have the technology. Let's make use of it. You cannot use the calculator with the computer algebra system. Nothing higher than TI-84 plus. If you have TI Inspired, I'll have to see your calculator and make sure that this is not a calculator system. If you don't know what calculator is, that's fine. Just put it on. Okay. I want you to graph this first and see if they intersect. And I simply want to find the area of the enclosed area. By enclosed, I mean enclosed by the two curves. Do we know how to graph? Okay. So we can graph the curves. You've got to put in the first function, which is x squared plus 1. Function number 2 is 3x minus 1. Yes, and graph. It is crossing somewhere. It's just not clear, right? You can do zoom 0, zoom 10, something like that, or you can do this. X value, let's say 0 up to 8. Y, I can go from 0 to 32. The intersection is right here. So maybe have to zoom 0. Is it zoom 0? Maybe not. I don't use the calculator, so I don't know. Probably not. But regardless, we can change the weighting. I think it's going to flash. I think it froze on me. But most of you here know how to graph it, right? So at this step, if you want to find the point of intersection using a calculator, go to second and trace. Second trace. You will get a list of options, and option number 5 is intersect. And just follow through the prompts. It'll ask you for the first curve, second curve, hit enter, enter, guess. You will get a point of intersection. Key things to note: you can't go way far away from the intersection and try to guess. You've got to come as close as possible to the point of intersection if you want to make a guess. Good? Sometimes it works, other times it doesn't. Mine froze, so I'm just going to let it go. How do we go about doing this manually? Thoughts? Go ahead.
You have to find the intersection point.
Louder, Hannah.
You have to find the intersection point first.
How do we find the intersection point?
Set them equal to each other.
Set them equal to each other. So x squared plus 1 equals 3x minus 1. Move everything to one side. X squared minus 3x plus 1 equals 0. Squared minus 3x plus 2 equals 0. How do you find?
You can just factor it out.
You can factor it. Should we be able to factor in this case?
Unless I did it wrong.
Yes or no?
I mean, I did it.
Go ahead. Easy.
I ended up with parentheses x minus 2, parentheses x minus 1.
That is correct. X minus 1 times x minus 2 equals 0. We didn't know how to factor, correct? Okay. So the point of intersection it happens that x is equal to 1 and x is equal to 2. So in between those 2 points, which curve is the upper curve and which is the lower curve? You can look in your calculator. I know which is which. Even without a calculator, when you plug in 1, what do we get in? Y equals x squared plus 1. 2, okay. When you plug in 1 in the second equation, you're going to get 2, yes? When you plug in 2, what do we get? First equation, say 5, yes? 2 squared plus 1, 5. Straight line, still get the same answer. Pick a number in the middle. This is 1,2, 1,5, 3 over 2. 3 over 2 squared is 9 over 4 plus 1. What is 9 over 4 plus 1? 13 over 4, okay. 3 point something. 9 over 4 minus 1. 27 over 4 minus 1, which is 23 over 4, definitely bigger than 13 over 4. So the line is on top, the curve is on the bottom. Good. You can zoom in, do all that magic. Not old school, I like it this way. Do it this way, makes it really sharp. Okay, meant to write 2 over there. F of x minus g of x, so upper curve, 3x minus 1. Lower curve, minus x squared plus 1. Use brackets, parentheses, so that you don't make mistakes. We know our limits of integration from 1 up to 2. So 1 to 2, 3x minus x squared minus 2 dx. Integral of that is 3x squared over 2 minus, what is the integral of x squared?
X to the third over x to the third.
Minus integral of 2 dx 2x plug in the upper limit. So 2 goes in there. First term would be 6 minus 8 over 3 minus 4. What should we do when we plug in the lower limit? What goes here? Evaluate the antiderivative or integral at the upper limit, lower limit. What goes in the middle? Minus. Very good. So low limit, 3 times 1 squared over 2, 3 over 2, minus 1 over 3, minus 2. Simply plugging in the upper limit and lower limit. Take the common denominator, it's negative 2 over 3. Minus 5 over 6 negative 2 over 3 plus 5 over 6, 1 over 6. And that is the final area. Good.